Whenever you look up at the night sky, you are met with a sense of wonder at the sheer, boundless scale of the universe. The cosmos is so much more than the empty space between the stars. It is a dynamic arena where fundamental processes give shape to matter, space, and time itself. Based on current astronomical calculations, the universe is about 13.8 billion years old, and over this immense period, it has evolved from elementary particles to the first stars and galaxies, presenting scientists with phenomena that continue to challenge our understanding. One of the most profound shifts in human thought came when we first understood that our world is just a minuscule point of light amidst a sea of innumerable stars. Furthermore, you must realize that every star you see is separated from us not by mere kilometers, but by light years, a unit that defines the distance light covers in 1 year. To put that into perspective, a single light year is equivalent to almost 10 trillion kilometers, a scale that utterly defies our everyday intuition of distance. Galaxies, stars, and planets all owe their existence to powerful gravitational forces that gather and compress vast clouds of gas and dust. Stars, for instance, are born from enormous nebulae composed of hydrogen and helium. As these clouds collapse under their own weight, their cores heat up until the temperature reaches millions of degrees, triggering the process of thermonuclear fusion. This ignition transforms them into radiant sources of light and heat, illuminating the surrounding space for billions of kilometers. Galaxies themselves are immense collections of billions of stars, gas, and dust, all held together in a gravitational embrace. Our own galaxy, which we call the Milky Way, is a spiral-shaped system that is home to more than 300 billion stars. This structure stretches over 100,000 light-years across, and our solar system is located within one of its spiral arms. Yet, as vast as it is, the Milky Way is just one of an uncountable number of galaxies scattered throughout the universe. With modern telescopes, astronomers can now peer at objects billions of light-years away, giving us a window into the universe's early history. Among the most incredible phenomena they've discovered are black holes, which are regions of space-time where gravity is so overwhelmingly strong that nothing, not even light, can escape. These cosmic traps are formed when a truly massive star runs out of fuel and collapses in on itself. There are even theories about supermassive black holes, with masses millions or billions of times that of our Sun, residing at the hearts of most galaxies, including our own. Beyond black holes, the cosmos is populated with a host of other perplexing objects. Neutron stars, for example, are the super-dense cores left behind by supernova explosions, where matter is crushed to an almost unimaginable degree. On Earth, a single teaspoon of material from a neutron star would have a mass of about 100 million tons. Because they are so dense and spin so rapidly, some of these stars emit beams of radiation that we detect as regular radio pulses, much like cosmic lighthouses guiding ships at sea. Of course, the universe is also awash with light and energy that our eyes cannot perceive, such as infrared, ultraviolet, X-ray, and gamma radiation. Observing in these wavelengths reveals a whole new spectrum of cosmic events, from exploding supernovas and colliding galaxies to the faint potential signals of dark matter. This is a mysterious substance believed to make up the majority of the universe's mass, yet it doesn't emit or interact with light at all. The universe isn't just immense, it is also incredibly dynamic. It has been in a state of continuous expansion ever since the Big Bang, and this expansion is actually getting faster. The driving force behind this acceleration is thought to be dark energy, another enigmatic component of the cosmos that represents one of the biggest puzzles in modern science. This expansion is what causes distant galaxies to move away from us more rapidly than closer ones, a fact confirmed by observing the redshift in their light spectra. Astronomers have also found planetary systems far stranger than our own, with planets that orbit multiple suns at once, or circle so close to their star that their atmospheres are boiled away by the intense heat. Thousands of these exoplanets have been catalogued, and some are situated in what is called the habitable zone. This is the orbital region where temperatures could potentially allow liquid water to exist on a planet's surface, which is a crucial condition for life as we currently understand it. Our solar system serves as a perfect example of the universe's dynamism and diversity on a smaller scale. At its center is the Sun, a G-type star located roughly 150 million kilometers from us, which contains more than 98% of the entire system's mass. The Sun's powerful gravity is what locks the planets into their orbits, while deep in its core, thermonuclear reactions fuse hydrogen into helium, unleashing the enormous energy that provides our planet with light and warmth. The planets in our solar system are broadly separated into two categories: the inner rocky worlds and the outer gas giants. The inner group consists of Mercury, Venus, Earth, and Mars, all of which are relatively small and have solid surfaces. Of these, Earth stands alone as the only world known to host liquid water and life, thanks in large part to its atmosphere of nitrogen, oxygen, and carbon dioxide, which is essential for regulating our climate and supporting biodiversity. Looking at our neighbors, you see a collection of extremes. Mercury, the planet closest to the Sun, endures incredible temperature shifts, from minus 160 degrees at night to 440 degrees in the daytime. Venus, often called Earth's twin, is anything but hospitable. It is veiled in a dense atmosphere of carbon dioxide and clouds of sulfuric acid, which have created a runaway greenhouse effect, making it the hottest planet in our system. Meanwhile, Mars, with its polar ice, ancient riverbeds, and frozen water reserves, remains a compelling destination for future human exploration. Further out, the gas giants, Jupiter and Saturn, are on a completely different scale, dwarfing Earth in both size and mass. Jupiter, the most massive planet in the solar system, possesses a formidable magnetic field that creates radiation belts intense enough to be a hazard for spacecraft. Its famous Great Red Spot is a gigantic storm, larger than our entire planet, that has been churning for hundreds of years. Saturn, of course, is celebrated for its spectacular system of rings, which are made up of countless particles of ice and rock. It's important to understand that Saturn's rings are not solid structures. They are actually divided into thousands of narrower bands, all interacting with the planet's numerous moons. The exact origin of these rings is still a subject of scientific inquiry, but one leading theory proposes that they could be the shattered remains of comets or small moons that were torn apart by the planet's immense gravity long ago. Uranus and Neptune are the solar system's ice giants, with methane-rich atmospheres that not only produce their distinct blue shades, but also fuel ferocious winds. You'll find that Uranus is particularly unusual because it rotates nearly on its side, a tilt that results in extreme seasons where a single hemisphere can be cast in darkness for over 42 years. Neptune, however, claims the title of the windiest location in our cosmic neighborhood, with supersonic gales that have been measured at speeds exceeding 2,000 kilometers per hour. The planets are accompanied by an array of natural satellites, each performing a vital role in the celestial architecture. While our own moon is responsible for stabilizing Earth's rotational axis and creating the tides, and Mars has its two diminutive companions, Phobos and Deimos, The gas giants host truly magnificent satellite systems. Jupiter, for example, boasts over 70 moons, including the 4 renowned Galilean moons. Io, which is the most volcanically active object in the solar system. Europa, whose icy crust may conceal a vast subsurface ocean. Ganymede, a world larger than the planet Mercury. And the ancient, heavily cratered Callisto. Saturn's moons offer you equally compelling worlds to explore. Its largest satellite, Titan, is a remarkable body enveloped in a thick, nitrogen-rich atmosphere where clouds of hydrocarbons precipitate methane rain. Then there is Enceladus, a moon that continues to astonish scientists with its mighty geysers, which spew water vapor and ice particles deep into space, making it a primary target in the continuing search for extraterrestrial life. You can visualize asteroids as the residual construction materials from the formation of the planets billions of years in the past. While numerous rocky bodies such as Ceres and Vesta inhabit the main asteroid belt situated between Mars and Jupiter, some follow more peculiar paths. A perfect example is Jupiter's Trojan asteroids, which are gravitationally locked in clusters at Lagrange points, moving in lockstep with the giant planet, and possibly safeguarding clues to the solar system's earliest history. Comets function as icy couriers, journeying from the outermost territories of our system, including the Kuiper Belt and the theoretical Oort cloud. As these conglomerations of ice, dust, and frozen gases make their approach to the sun, they heat up and begin to vaporize, forming the spectacular, brilliant tails you can sometimes observe from Earth. By preserving ancient material, these cosmic voyagers enable astronomers to reconstruct events from billions of years ago, including the processes by which water and organic compounds may have originally reached our world. Occupying a classification between planets and asteroids, you have dwarf planets such as Pluto and Eris, which frequently display surprising features like complex atmospheres or ice volcanoes. The fragments of asteroids or comets that manage to survive a blazing passage through our atmosphere and land on the surface are what we call meteorites. These objects, which produce the streaks of light you know as shooting stars, vary in composition from iron to stone, and can carry unique minerals and organic compounds that provide us with tangible glimpses into the universe's past. When I refer to the sounds of space, you should understand that I am not talking about acoustic waves moving through a void. What you are actually hearing are electromagnetic oscillations and plasma interactions that have been translated into audible frequencies. For instance, the radio waves produced by disturbances in a planet's magnetosphere or by immense solar flares can be recorded and converted into signals that let us listen to the activity of the cosmos. Engaging with these cosmic recordings, especially as you prepare for sleep, can foster a profound feeling of unity with the universe, encouraging both relaxation and contemplation. The experience is akin to being carried into orbit, where you can observe the silent ballet of moons and the majestic rotation of gas giants. In these moments, you can feel the fundamental rhythm of the cosmos, a harmony that has resonated across billions of years. You should also recognize that events in space have a direct and powerful influence on our life on Earth. Phenomena like solar flares and coronal mass ejections can initiate potent magnetic storms, capable of disrupting our satellites, our navigation systems, and even our power grids. On a grander scale, the continuous stream of solar and interstellar particles shapes everything from the formation of clouds in our atmosphere to long-term patterns in the global climate. Ultimately, when you gaze at the night sky, which may appear peaceful and unchanging, It's important to remember that you are looking at a portal to an incredibly dynamic and evolving cosmos. The solar system serves as a perfect microcosm of the universe's energy and wonder, where every single object tells a story of the past and future, all governed by the fundamental laws of nature. Exploring these objects is a way for you to appreciate the profound interconnectedness of our own world within this immense and magnificent expanse. Consider, for example, Halley's Comet, which reappears every 75 years, giving scientists a recurring opportunity to study how its structure and composition evolve over time. Celestial bodies like asteroids and comets are not just sources of fascination, they also have a tangible impact on Earth. You can witness events like the Perseids or Geminids meteor showers when our planet traverses the orbital paths littered with cometary debris. As these minuscule particles plunge into our atmosphere, they ignite and burn, tracing luminous streaks across the sky that we call meteors. These spectacular celestial events, so clearly visible against the backdrop of the night, can inspire a profound sense of tranquility and awe, particularly when you observe them just before drifting off to sleep. For generations, humanity has been captivated by the dream of traveling through space. Those dreams began to materialize in the 20th century, starting with the deployment of the first artificial satellites. The launch of Sputnik 1 in 1957 officially inaugurated the era of space exploration. This pivotal moment was soon followed by crewed missions, crowned by the extraordinary flight of Yuri Gagarin, who became the first human to ever orbit our planet. Such achievements motivated countless people and proved that space was a realm not just for observation, but for direct human exploration. The International Space Station stands as a testament to modern human collaboration in the conquest of space. As it orbits Earth at an altitude of roughly 400 kilometers, its crew lives and works in a microgravity environment, conducting research into biological, physical, and astronomical phenomena. Their work is crucial for helping us comprehend how life might survive beyond our world, and for developing the technologies essential for future voyages to the Moon, Mars, and even more distant destinations. Our understanding of asteroids and comets is continually being deepened by robotic missions. Spacecraft such as Hayabusa and Rosetta have successfully retrieved samples from these distant bodies, enabling scientists to examine their chemical makeup and internal structure with unparalleled detail. These missions do more than just unlock secrets about the solar system's formation. They are also paving the way for safer human space travel in the years to come. Looking ahead, scientific ambitions are set on exploring objects far beyond our own solar system, with a particular focus on exoplanets that circle other stars. These investigations aim to reveal just how unique our own planet is, and to probe the possibility of life existing elsewhere in the galaxy. Powerful instruments like the James Webb Space Telescope and its future successors are already discovering previously invisible objects, providing us with incredible glimpses into the universe's origins and its deepest enigmas. The sights and sounds of the cosmos offer a powerful combination for deep relaxation. If you picture fields of asteroids drifting silently, comets painting shimmering tails across the void, and space stations watching over the Earth, you can begin to feel their calming effect. This imagery and the accompanying sounds can help you unwind, find a meditative focus, and prepare your consciousness for a night of restorative sleep. In this way, asteroids, comets, and our collective journey into the cosmos not only broaden our knowledge of the universe, but also cultivate a deeper connection to its immense scale. By studying these celestial phenomena, you can attune yourself to the harmony of cosmic rhythms and motions, immersing yourself in a grandeur and serenity that is perfectly suited for evening reflection and a peaceful transition into sleep. When you gaze up at the night sky, the stars might seem to be scattered at random. However, with the aid of powerful telescopes, you can perceive immense clouds of gas and dust known as nebulae, which are the cosmic nurseries where new stars are born. These interstellar formations are gigantic, often spanning hundreds of light years, and they manifest in several forms, including emission, reflection, dark, and planetary nebulae. Emission nebulae, for instance, are set aglow by ionized gas that is energized by the intense radiation from hot, nearby stars. A prime example is the Orion Nebula, one of the most thoroughly examined objects of its kind, which you can even spot with the unaided eye as a hazy patch in the winter sky. Within these cosmic clouds, embryonic stars called protostars take shape over millions of years through a process of gravitational collapse, where dense pockets of gas and dust coalesce and heat up until nuclear fusion ignites in their cores. Many nebulae are famous for their breathtaking beauty and rich palettes, which actually serve as indicators of their chemical makeup. Hydrogen typically glows with a red light, oxygen emits shades of green or blue, and nitrogen contributes a reddish hue. These vibrant cosmic canvases are not only a feast for the eyes, but also provide astronomers with vital clues about the chemical processes occurring within these immense stellar nurseries. Star clusters are born within nebulae, representing groups of stars that all formed from the same parent cloud at roughly the same time. These can be categorized as either open clusters, like the Pleiades, which contain tens to hundreds of stars and are often visible without a telescope, or globular clusters, which are ancient, dense spheres of hundreds of thousands of stars, some over 10 billion years old. These stellar collections offer invaluable insights into the life cycles of stars and the evolution of entire galaxies. Lurking deep in space are dark nebulae, which are regions so densely packed with dust that they completely block the light from stars situated behind them. These formations create dramatic silhouettes against brighter cosmic backgrounds and conceal the nascent stages of star formation within their depths. It is in these obscured regions that new suns are born, destined to one day become new beacons of light and energy in the universe. Equally enigmatic are the interstellar travelers, such as rogue planets and massive compact objects, which drift untethered to any star system, helping us appreciate the universe's dynamic and diverse nature. Humanity has always been driven by the desire to explore these remote cosmic landscapes. Today's advanced instruments, including the Hubble Space Telescope and its successors, grant us the ability to peer across billions of light years into the past. By capturing the faint light from ancient galaxies, these telescopes allow us to witness the early phases of the universe's development, revealing how the very first stars ignited and how galaxies assembled and evolved over cosmic time. Allowing your mind to meditate on the imagery of nebulae and the birth of stars can be a profound way to relax and connect with the sheer scale of the universe. Imagine the slow, swirling dance of gas and dust clouds, the first flicker of new stars igniting within them, and the harmonious rhythm of billions of suns across the cosmos. These mental pictures can induce a state of deep calm, wash away stress, and prepare you for a truly restful sleep. Beyond offering scientific knowledge, nebulae, star formation, and the deep cosmos provide profound visual and emotional experiences. They help you feel a sense of connection to the boundless expanse of the universe, making them a perfect subject for evening relaxation and sleep. When exploring space, it is impossible to ignore its most powerful and mysterious objects: black holes and neutron stars. A black hole represents a region of space-time where gravity is so overwhelming that nothing, not even light, can escape. formed when a massive star collapses under its own gravitational force at the end of its life. These cosmic phenomena are categorized into stellar, supermassive, and intermediate types. Stellar black holes emerge from stars that are tens of times more massive than our Sun, whereas supermassive black holes, with masses millions to billions of times greater than the Sun's, are found at the centers of galaxies. Observing black holes directly is impossible because their event horizons trap all light. However, astronomers use space and radio telescopes to detect the intense radiation produced by matter as it spirals into them. As this gas and dust accelerate inward, it heats to millions of degrees, emitting powerful X-rays and gamma rays, a signature that allowed for the first ever image of the event horizon of the supermassive black hole in the galaxy M87. Neutron stars are another class of exotic objects that form from the collapse of massive stars not quite large enough to become black holes. Their density is almost incomprehensible. A single teaspoon of neutron star material would weigh about 1 billion tons. Some neutron stars rotate rapidly and possess powerful magnetic fields, sweeping beams of radio waves through space like cosmic lighthouses, which we observe as pulsars of extraordinary regularity. Scientists also theorize about even more exotic objects, like quark stars and strange stars, which serve as a testament to the universe's diversity and the extreme physical laws that fascinate anyone who studies them. Black holes and neutron stars do more than just captivate scientists. They are fundamental in shaping the dynamics of galaxies, with their gravitational pull orchestrating the orbits of stars and gas clouds. The merger of two black holes or neutron stars creates gravitational waves, which are now detectable by advanced observatories like the Laser Interferometer Gravitational Wave Observatory, or LIGO, and Virgo. These events have opened up an entirely new way to study gravity, affirming Einstein's predictions and giving us a fresh window into the cosmos. Additionally, some black holes launch jets of high-energy particles that travel for thousands of light years, influencing the surrounding interstellar space and setting the stage for the formation of new stars and galaxies, showing how even destructive objects can be cosmic architects. For meditation and unwinding before sleep, visualizing these powerful objects can help you grasp the sheer scale and majesty of the cosmos. If you imagine invisible gravity warping the fabric of space-time, or light bending around these massive bodies, you can peacefully contemplate the universe's power and find a sense of harmony in its natural laws and rhythms. Thus, black holes, neutron stars, and other exotic objects not only impress us with their grandeur, but also expand the frontiers of scientific understanding, helping us comprehend how galaxies form and evolve. When you gaze into the night sky, the stars might seem scattered without order, but on a cosmic scale they are organized into immense structures known as galaxies. A galaxy is a massive, gravitationally bound system composed of billions of stars, gas, dust, and the elusive substance called dark matter. Galaxies vary enormously in size, from a few thousand to hundreds of thousands of light years across, and are classified into different shapes, including spiral, elliptical, irregular, and lenticular. Spiral galaxies, such as our own Milky Way, are characterized by distinct arms where new stars are actively forming, while elliptical galaxies have a more uniform appearance and are typically home to older, more mature stars. Holding these vast structures together is dark matter, a mysterious component of the universe that we can only detect through its gravitational influence on visible matter. Without dark matter, the outer stars and galaxies would be moving too fast to stay in orbit and would simply fly off into deep space. Scientists calculate that dark matter accounts for approximately 85% of the universe's total mass. Because it doesn't interact with electromagnetic radiation, it's invisible to all our telescopes, and its presence is inferred only from its gravitational effects. Galaxies themselves are not static. They interact with one another over billions of years, leading to spectacular cosmic events such as galactic collisions and mergers, which profoundly alter their structures. Our Milky Way is, in fact, on a collision course with the Andromeda Galaxy, an event expected in a few billion years. On an even larger scale, galaxies are gravitationally bound into groups and clusters, moving at speeds of hundreds of kilometers per second through intergalactic space. This space is not empty, but filled with clouds of hot gas reaching temperatures of tens of millions of degrees, which emits X-rays detectable by our space observatories. Studying these clusters is a key method for investigating dark matter, as its presence governs the distribution of all the visible matter. These galactic structures create stunning visual effects that impress even professional astronomers, from galaxies with graceful spiral arms to those with active nuclei that emit powerful jets of high-energy particles. These active galaxies serve as cosmic laboratories for studying processes like the formation of supermassive black holes and the birth of new star systems. As you prepare for sleep, visualizing these galaxies and their grand interactions can help you connect with the scale and harmony of the universe. This mental imagery allows for a peaceful contemplation of cosmic power, helping you find a sense of tranquility in the universe's natural laws and rhythms before you rest. Envision the majestic spiral arms turning in a slow cosmic dance, where a gentle radiance is cast by billions of stars, all held together in their orbits by unseen dark matter. These mental pictures can induce a state of profound relaxation, letting your mind connect with the universe and feel the harmony of its immense expanses. This is why exploring galaxies, their forms, their interplay, and the enigma of dark matter does more than just teach us scientific truths. It allows us to feel the sheer scale and magnificence of the cosmos. Contemplating these cosmic processes helps cultivate a sense of deep serenity and inner peace, making it an ideal practice for unwinding at night and preparing for sleep. When you think about space, your imagination likely gravitates toward the planets that circle our sun. The solar system is a community of 8 planets orbiting at different distances, along with an assortment of dwarf planets, asteroids, and comets that also call it home. These planets are sorted into 2 distinct categories: the inner, rocky worlds of Mercury, Venus, Earth, and Mars, and the outer gas giants, which include Jupiter, Saturn, Uranus, and Neptune. Every one of these worlds is defined by its own unique qualities, from its atmosphere and geological makeup to its family of moons. Mercury, positioned closest to the Sun, endures incredible temperature swings, with its surface heating up to 440 degrees Celsius by day, and then dropping to a frigid minus 180 degrees at night. The planet's nearly non-existent atmosphere means solar radiation directly bakes its surface. In a discovery that took scientists by surprise, ice was found concealed within the permanently shadowed craters at Mercury's poles. Meanwhile, Venus, often called Earth's sister planet, is veiled by a thick atmosphere of carbon dioxide, featuring clouds composed of sulfuric acid. The atmospheric pressure at its surface is a crushing 92 times greater than Earth's, while temperatures soar to nearly 500 degrees Celsius. Our world, Earth, stands as a unique haven in the cosmos, possessing liquid water, an atmosphere rich in oxygen, and a magnetic field that shields life from harmful cosmic rays. The presence of our moon drives the ocean tides and, through its gravitational influence, stabilizes the tilt of our planet's axis, which in turn helps create the conditions necessary for a relatively stable climate. Mars, widely known as the Red Planet, is distinguished by its vast deserts, deep canyons, and the colossal volcano Olympus Mons, which rises to a height of over 21 kilometers. This world captivates scientists with evidence of ancient water and its potential as a site for future human settlement. Its thin atmosphere contributes to its cold climate, where temperatures can fall as low as -120 degrees Celsius. Jupiter, the true giant of our solar system, exerts the most powerful gravity and is orbited by more than 70 moons. Its most famous moon, Ganymede, is the largest in the entire solar system, even exceeding the size of Mercury. Jupiter is also recognized for its Great Red Spot, a gigantic storm that has been churning for centuries, and for its intensely powerful radiation belts. Saturn is celebrated for its spectacular system of rings, which are made up of countless particles of ice, dust, and rock. These rings stretch for hundreds of thousands of kilometers across, but are, remarkably, only a few hundred meters thick. Saturn is also accompanied by over 80 moons, among them Titan, an extraordinary world with a thick atmosphere and lakes of liquid hydrocarbons on its surface. Positioned on the far edges of the solar system are Uranus and Neptune, the ice giants. Uranus has a highly unusual rotation, spinning almost on its side, which leads to extreme seasons where one pole can be bathed in sunlight for decades at a time. Neptune, despite its great distance from the Sun, experiences the most powerful winds in the solar system, with gusts reaching 2,000 kilometers per hour, and hosts dynamic storm systems that are regularly tracked by telescopes. In the more remote areas of the solar system, you'll find dwarf planets like Pluto, Ceres, and Eris. Although they are much smaller and do not gravitationally command their orbital paths, investigating these bodies is crucial for understanding how our system formed and evolved, and for tracing the origins of comets and asteroids. The gravitational dance between the planets creates an intricate system where every world subtly influences its neighbors. To aid in your bedtime meditation, try visualizing these planets, which can help you relax and appreciate the scale of the cosmos. See Mercury and Venus circling near the Sun, with Earth and Mars tracing their own orbits, while the gas giants move in a grand, harmonious rhythm. Such imagery can soothe the mind, encouraging a feeling of peace and a profound connection with the universe. Space is populated not just by planets and stars, but also by innumerable smaller objects that have played a vital role in the history of our solar system. Asteroids are rocky or metallic bodies that orbit the Sun, with the majority concentrated in the main asteroid belt located between Mars and Jupiter. This region contains millions of objects, from small rocks to bodies hundreds of kilometers in diameter, all formed from primordial material that failed to merge into a planet. Some of these asteroids have orbits that bring them close to Earth. These are known as near-Earth objects. Scientists monitor them not only to safeguard our planet from potential impacts, but also because they represent possible sources of valuable resources for the future. Missions like OSIRIS-REx and Hayabusa have successfully brought back samples from asteroids, enabling researchers to study their composition with unprecedented accuracy and learn more about the solar system's origins. Comets, on the other hand, are icy travelers composed of dust and frozen gases, following highly elongated orbits around the Sun. When a comet approaches our star, the heat causes its surface ice to sublimate, creating a brilliant tail of gas and dust that always points away from the Sun. A comet's tail can extend for millions of kilometers and, on occasion, becomes bright enough to be seen from Earth without a telescope. Because comets are composed of primitive materials that have been preserved since the formation of our solar system, they offer you a unique glimpse billions of years into the past. Studying them reveals the chemical composition of the earliest celestial objects. Similarly, trans-Neptunian objects, which reside beyond Neptune's orbit, are also crucial. These include dwarf planets like Pluto and Eris, which are remnants of the original protoplanetary disk, and help scientists understand accretion and planetary migration. Asteroids and comets serve as essential vehicles for organic matter and water, and it's thought that a portion of Earth's water was delivered by them during an intense bombardment roughly 4 billion years ago. These events connect these small celestial bodies directly to the emergence of conditions on our planet that were favorable for life. The unusual orbits of some of these objects, which cross planetary paths, make them fascinating subjects for studying celestial dynamics, as gravitational forces can redirect them or even eject them from the solar system entirely. For a moment of meditation before sleep, visualizing these bodies can help you connect with the scale and harmony of the cosmos. Imagine millions of rocky asteroids slowly journeying around the sun, icy comets trailing their luminous tails, and distant dwarf planets tracing their orbital paths. These mental images can create a profound sense of tranquility, reminding you that every element in the universe, no matter how small, follows a beautiful and harmonious cosmic order. The sun is far more than just a brilliant star in our sky. It is the fundamental source of life for our entire planetary system. Classified as a yellow dwarf, this medium-sized star has a diameter exceeding 1,400,000 kilometers, making it nearly 109 times larger than Earth. Its mass is approximately 2 octillion tons, which means it constitutes over 99% of the solar system's total mass. Deep within the sun's core, thermonuclear reactions are constantly taking place, where hydrogen atoms fuse to create helium in a process known as nuclear fusion. This transformation releases immense quantities of energy in the form of light and heat. The core itself reaches a temperature of about 15 million degrees Celsius, under pressures that exceed millions of atmospheres, and the energy generated there takes thousands of years to travel to the surface, through the radiative and convective zones. The visible surface of the sun that we observe from Earth is called the photosphere, and it has a temperature of around 5,500 degrees Celsius. On this surface, cooler areas with intense magnetic activity, known as sunspots, appear and disappear in solar cycles that last roughly 11 years. These cycles directly influence solar activity, leading to phenomena like solar flares and coronal mass ejections. The sun's outer atmosphere, the corona, extends for millions of kilometers into space and mysteriously reaches temperatures of 1 million degrees Celsius, far hotter than the photosphere below it. This region emits X-rays and ultraviolet radiation, and it generates the solar wind, a continuous stream of charged particles that flows throughout the solar system. This wind interacts with planetary magnetospheres, creating spectacular auroras on planets like Earth, Jupiter, and Saturn. Solar flares are powerful bursts of energy that can travel to Earth's orbit in just 8 minutes, capable of causing geomagnetic storms that disrupt satellites, radio communications, and even power grids. Despite these potential hazards, these phenomena also produce stunning light displays in planetary atmospheres and are a key area of study for understanding stellar physics. The sun's incredible gravity is also what maintains the balance of our solar system, holding all planets, asteroids, and comets in their orbits, and ensuring the system's stability for billions of years. For a nighttime meditation, you can visualize the sun to feel its warmth and its harmonious influence on the entire system. Picture its radiant core as energy slowly moves outward. Imagine the dance of sunspots on its surface, and see the gentle light that ultimately reaches Earth. Contemplating these images can evoke a feeling of security and peace, reminding you of the universe's profound grandeur and perfect harmony. The Moon is the closest celestial body to our planet, and humanity has shared a deep connection with it for millennia. As Earth's only natural satellite, it orbits at an average distance of about 384,000 kilometers and has a major impact on life here. One of its most visible effects is the creation of ocean tides, which are caused by its gravitational pull. This process helps maintain a dynamic equilibrium in our planet's water systems, contributing to climate stability. The origin of the Moon is still a topic of active scientific debate, but the most widely accepted theory is the giant impact hypothesis. This theory proposes that the Moon formed from the debris of a massive collision between a very young Earth and a protoplanetary body named Theia. Evidence from the Apollo missions and automated probes, which show that lunar rocks have chemical and isotopic compositions similar to Earth's crust, lends strong support to this idea. The Moon's surface is a landscape of stark and beautiful contrasts, featuring bright, ancient highlands alongside dark plains called Maria, which were created by immense lava flows in the distant past. The entire surface is covered in craters, which serve as a preserved record of billions of years of meteorite bombardment. By studying these features, scientists can piece together the long and often violent history of our solar system. The Moon's most enormous crater, known as the South Pole Aitken Basin, measures approximately 1,200 kilometers across and descends to a depth of over 8 kilometers. With a gravitational pull that is only about 1/6 of our planet's, moving on the lunar surface is a peculiar experience, where your steps feel lighter and your leaps carry you higher. Because it lacks an atmosphere, the Moon is immune to wind erosion, allowing its craters and other geological formations to stay perfectly preserved for billions of years, while its surface endures extreme temperature shifts, soaring to 125 degrees Celsius in the daytime, before dropping to a frigid -180 degrees at night. The Moon exerts a considerable influence on both the magnetic field and the rotation of our planet. Extensive research indicates that the Moon is slowly drifting away from Earth at a rate of several centimeters per year. This gradual separation causes Earth's rotation to decelerate, thereby extending the length of our day. These interconnected processes have been unfolding over billions of years, illustrating the fine-tuned gravitational balance that exists between these two celestial partners. To help you relax at night, try visualizing the Moon, which can foster a profound sense of harmony and a feeling of connection to the cosmos. Envision its gentle silvery glow reflecting upon Earth's oceans and continents, the deep quiet of its ancient craters, and the serene stillness of its lunar Maria. Contemplating these scenes can instill an inner calm, guiding your mind into a meditative state that encourages deep relaxation and restorative sleep. The Moon also stands as a primary target for upcoming space exploration initiatives. Ambitious plans are underway to send humans back to its surface, construct permanent outposts, and investigate its resources, including the ice believed to be trapped within its shadowed craters. Such endeavors promise to usher in a new era of cosmic discovery. Delving into the Moon's secrets not only enhances our knowledge of Earth and the solar system's origins, but also motivates humanity to pursue new breakthroughs and achievements in space science. More than just objects of scientific curiosity, asteroids and meteorites serve as genuine envoys from the dawn of the solar system. Asteroids are the rocky and metallic remnants from our solar system's formation, with the majority orbiting in the main asteroid belt situated between Mars and Jupiter, though some have trajectories that intersect with Earth's. These near-Earth asteroids are of immense scientific interest because they hold primordial materials that have been unchanged since the planets first formed, giving you a direct look at the early chemical makeup of our cosmic neighborhood. Meteorites are the fragments of asteroids, comets, or even planets like Mars and the Moon that have fallen to Earth. They are generally classified as stony, iron, or a combination of the two, and each category possesses distinct minerals and isotopes that enable scientists to pinpoint their age. The most ancient meteorites are dated to over 4.5 billion years old, positioning them as direct witnesses to the formative stages of the solar system. While impacts on Earth happen continually, most of these objects incinerate in the atmosphere, creating the fleeting streaks of light you know as meteors or shooting stars. The fragments that survive the journey and land on the surface are what we call meteorites. By examining these celestial visitors, we can better comprehend how planets came to be, what raw materials were present for the rise of life, and the ways in which cataclysmic events have molded our world's history. A few massive asteroids and meteorites have left an indelible mark on our planet's story. For instance, the collision of an asteroid measuring roughly 10 kilometers in diameter, which occurred 66 million years ago, triggered catastrophic changes to the climate and ecosystems, contributing significantly to the extinction of the dinosaurs. Such occurrences underscore the critical need for monitoring objects near Earth and for inventing technologies that can safeguard our planet from future threats. A fascinating aspect of asteroids is their sheer variety. You can find silicate-heavy asteroids, metallic ones composed of iron and nickel, and carbonaceous asteroids which contain organic compounds. The carbonaceous types are particularly prized by scientists because they may harbor amino acids and other molecules that are considered fundamental to the emergence of life. Meteorites frequently carry deep cultural and historical weight, with some finds becoming prized museum displays, while others serve as inspiration for artists and authors. Advanced space missions, such as OSIRIS-REx and Hayabusa, have successfully retrieved samples from asteroids and brought them to Earth, allowing for an unparalleled level of precision in analyzing their chemistry and structure. OSIRIS-REx, for example, returned material from the asteroid Bennu, while the Japanese Hayabusa mission brought back samples from the asteroid Ryugu, opening new frontiers in our study of these cosmic bodies. For unwinding before sleep, you might find it beneficial to imagine a vast expanse of space teeming with millions of asteroids and meteorites. Picture these bodies gliding slowly on their orbital paths, with occasional pieces breaking away and descending to Earth as luminous trails across the sky. These mental images can foster a sense of tranquility and awe, helping you connect with the universe's grandeur and dynamism while preparing for a deep and peaceful rest. In essence, asteroids and meteorites do more than just unlock the solar system's past. They also deepen our grasp of cosmic mechanics and how they affect Earth. These objects are a powerful reminder that even the most unassuming celestial bodies can possess enormous scientific and existential importance. The solar system's gas giants are genuine behemoths, dwarfing Earth on almost every scale. These planets fall into two classifications: the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. Composed predominantly of hydrogen and helium, the gas giants are defined by their immense atmospheres, powerful magnetic fields, and swift rotations. Their mass is anywhere from tens to hundreds of times greater than Earth's, establishing them as gravitational anchors for countless moons and asteroids. Jupiter reigns as the most massive planet in our solar system, boasting a diameter of over 1,400,000 kilometers and a mass exceeding 320 times that of Earth. Its atmosphere is a dynamic canvas of distinct cloud bands and colossal storms, most notably the Great Red Spot, a gigantic anticyclonic storm that has been raging for centuries. Furthermore, Jupiter possesses the most powerful magnetic field in the solar system, which generates intense radiation belts that are a significant hazard to any passing spacecraft. Saturn is distinguished by its magnificent rings, which are made up of countless particles of ice and rock that vary in size from tiny crystals to chunks several meters across. This signature feature of Saturn is a one-of-a-kind spectacle that we have yet to fully comprehend. The rings reflect sunlight, producing stunning visual displays, while their continuous gravitational interactions with Saturn's many moons create a complex and ever-shifting system. Further out, you find Uranus and Neptune, ice giants that are less massive than Jupiter and Saturn, but still dwarf our own Earth. Their atmospheres are rich in methane, which is what gives them their characteristic blue-green appearance. These planets also possess strange rotational characteristics. Uranus is tilted almost completely onto its side, whereas Neptune experiences the most violent wind activity in the solar system, with speeds exceeding 2,000 kilometers per hour. It's also worth paying close attention to the moons of these giant planets. Jupiter boasts a collection of more than 80 moons, among which are the Galilean moons, Io, Europa, Ganymede, and Callisto, that serve as prime locations in the search for potential life. With its icy shell covering a subsurface ocean, Europa stands out as a particularly compelling target for future missions. Meanwhile, Saturn's moon Titan features a thick atmosphere and lakes of methane, and its moon Enceladus is geologically active, spewing geysers of water vapor. The giant planets perform a vital service in safeguarding the inner solar system. Their immense gravitational pull serves to capture or redirect comets and asteroids, thereby reducing the likelihood of catastrophic impacts with Earth. You can think of this as a cosmic shield that helps maintain the stable conditions necessary for life to thrive on the inner, rocky planets. To help yourself unwind before falling asleep, you might find it useful to picture these colossal worlds in your mind. Imagine Jupiter's enormous, swirling cloud bands, Saturn's radiant rings, and the cool, icy shades of Uranus and Neptune. Picture their many moons making their slow, graceful circuits around them, with sunlight softly glancing off their surfaces and creating serene images that can guide you into a deep and restful sleep. These giant planets are far more than just immense celestial objects. They are entire miniature systems, each with its own distinctive characteristics. Their presence shapes the mechanics of the whole solar system, presenting endless possibilities for both scientific discovery and the boundless reach of your own imagination. Among the most enigmatic and lovely sights in our solar system are the comets. These are small celestial bodies composed of ice, dust, and frozen gases. While a comet's solid nucleus might only be a few kilometers wide, its journey toward the sun causes it to heat up and release gas and dust, forming a luminous atmosphere known as a coma and an extended tail that perpetually points away from the sun, sometimes stretching for millions of kilometers. Comets are generally categorized into two distinct groups: short-period comets, which complete an orbit in under 200 years, and long-period comets, which complete an orbit in over 200 years. Comets, whose orbits can span thousands or even millions of years. Predictable visitors like Halley's Comet are short-period comets that have been observed since ancient times, while the rare appearances of long-period comets could only be documented after the invention of powerful telescopes and modern observation methods. The genesis of comets is tied to the most remote parts of our solar system, specifically the Kuiper Belt and the Oort cloud. These vast, cold regions are home to billions of icy objects that have been preserved since the planets first formed. When these bodies are nudged from their distant homes and travel inward, they function as envoys from the early universe, carrying invaluable data about the raw materials that created our planetary system. As a comet draws near the sun, the increasing warmth triggers a process called sublimation, where ice transforms directly into gas. This outgassing creates the coma and the iconic tail. The released particles of dust and gas then interact with the solar wind to form two separate tails. One is a gas tail of ionized particles that points straight away from the sun, and the other is a dust tail of heavier material that often displays a slight curve because of its orbital momentum. Comets are believed to have had a crucial influence on Earth's history and the origin of life itself. A prominent hypothesis suggests that comets were responsible for delivering water and organic molecules to our young planet, providing the fundamental ingredients for life to begin. Scientific analysis of their icy makeup has confirmed the existence of amino acids and other complex organic compounds, elevating their importance for research. Witnessing a comet firsthand is one of the most remarkable experiences in astronomy. To calm your mind before sleep, you can try visualizing a comet gliding silently across the vastness of the night sky, its brilliant tail illuminated by sunlight. Such mental images can conjure a feeling of cosmic grandeur and harmony, nurturing a tranquil and meditative state perfect for rest. Modern scientific missions are now studying comets at very close range. The notable example is the European Space Agency's Rosetta spacecraft, which rendezvoused with comet Churyumov-Gerasimenko and successfully deployed its Philae lander onto the surface. These investigations yield priceless information on the comet's density, the composition of its materials, and the complex physical processes at play, enriching our understanding of planet formation and the solar system's history. Comets serve as a constant reminder of the ancient and dynamic reality of the cosmos. As they follow their orbits, sometimes crossing the paths of planets before disappearing back into deep space, they continue to fascinate scientists and amateur skygazers alike. Picturing their majestic journeys before sleep can foster a profound sense of harmony with the universe, allowing you to appreciate both its immensity and its serenity. Among the other fascinating bodies in our celestial neighborhood are Trojan asteroids and near-Earth objects, which have a significant impact on the solar system's mechanics. Trojans are a special class of asteroid that occupy stable gravitational zones, known as Lagrange points, of larger planets, most notably Jupiter. They are organized into two clusters, one 60 degrees ahead of the planet and one 60 degrees behind, which keeps their orbit stable for billions of years, making them a veritable cosmic museum of primordial material. With more than 7,000 catalogued objects, Jupiter commands the largest population of Trojan asteroids, a number that consistently climbs as our observation capabilities improve. These Trojans harbor a mix of minerals and organic materials, which makes them incredibly valuable for investigating the early chemistry of the cosmos and the formative conditions of planets. Some theories even propose that these celestial bodies could have delivered the organic building blocks to a young Earth, playing a role in the processes that led to life. Asteroids that have orbits intersecting or passing near our own are known as near-Earth objects. Their sizes can vary dramatically, from just a few meters across to several tens of kilometers in diameter. Although the majority pose no danger, a fraction of them represent a potential collision threat to our world. Consequently, tracking these objects has become a top priority in astronomy, since mapping their trajectories is key to predicting impacts and devising effective defense plans. Near-Earth objects are categorized into orbital classes known as Amor, Apollo, and Aten asteroids, with each group possessing unique characteristics and a different level of potential risk. For instance, Apollo asteroids are defined by orbits that cross Earth's path and have a wider semi-major axis, whereas Aten asteroids have a smaller semi-major axis and largely stay within our planet's orbit. These distinctions allow astronomers to model the most probable scenarios for any future encounters with Earth. Certain near-Earth objects display quite peculiar physical traits, including extremely fast rotations, highly irregular shapes, or compositions rich in rare metals. By studying these asteroids, you gain a deeper understanding of the internal composition and history of rocky bodies throughout the solar system. Furthermore, they are viewed as promising repositories of valuable minerals for upcoming space missions, creating new avenues for cosmic exploration and the use of resources beyond our planet. To help you unwind before sleep, I suggest you try picturing these asteroids gliding slowly along their orbital paths. Imagine Jupiter's Trojans standing as sentinels for the gas giant, their synchronized movements creating a sense of cosmic balance. See the near-Earth asteroids as they drift by at a safe remove, sparkling like distant jewels in the sun's light. These mental images can guide you into a state of profound relaxation and a feeling of oneness with the universal rhythm. Several prominent Trojan asteroids have become targets for spacecraft, which has significantly enhanced our comprehension of their part in the solar system's development. A key example is the Lucy mission from the National Aeronautics and Space Administration, which is engineered to investigate multiple Jupiter Trojans at the Lagrange points of its orbit. The goal is to learn about their makeup, origins, and orbital behavior, which will ultimately give us a clearer picture of how our cosmic neighborhood came to be. In essence, both Trojan asteroids and near-Earth objects offer you a unique glimpse into the solar system's deep past, while also holding potential importance for humanity's future. They are simultaneously custodians of ancient knowledge and vivid reminders that space is an active and evolving stage, where every celestial object plays a meaningful role. The sun is so much more than the brilliant star you see in the sky. It is the central power source for our entire solar system. Classified as a G-type main sequence star, or a yellow dwarf, it sits roughly 150 million kilometers away from us. Its diameter stretches over 1,400,000 kilometers, and its mass is an astonishing 930,000 times greater than Earth's. Composed mostly of hydrogen and helium, the sun's core operates as a gigantic thermonuclear reactor, fusing hydrogen into helium and unleashing tremendous energy as light and heat. The sun's interior is comprised of distinct layers, beginning with the core at its very center, where all nuclear reactions take place. This core accounts for about 25% of the sun's total radius and burns at a temperature of approximately 15 million degrees Celsius. Energy generated here travels outward, first through the radiative zone in the form of photons, and then into the convective zone, where it is transported by massive currents of superheated plasma. The visible surface of the sun that you perceive from Earth is called the photosphere, which has a temperature around 6,000 degrees Celsius. Just above it are the chromosphere and the corona, which form the sun's incredibly hot outer atmosphere, with temperatures reaching into the millions of degrees. Extending far into space, the corona is the source of the solar wind, a constant stream of charged particles that bathes every planet in our solar system. Solar activity takes many forms, such as sunspots, prominences, powerful solar flares, and immense coronal mass ejections. Sunspots are cooler, darker patches on the photosphere created by intense magnetic fields. These areas frequently give rise to flares, which are abrupt and violent explosions of energy that can impact Earth by creating brilliant auroras and disrupting satellite and radio signals. Solar storms and coronal mass ejections are the primary drivers of what we call space weather. When a major ejection is directed toward us, it can cross the distance to Earth in just 1 to 3 days and induce a geomagnetic storm. While these events produce spectacular atmospheric light shows like the northern and southern lights, they also have the power to interfere with our communication networks, electronics, and navigation systems, reminding us of the dynamic cosmic forces at work. Ultimately, the sun is the deciding factor for Earth's climate and its capacity to support life. The light and heat it provides regulate our planet's temperature, drive atmospheric phenomena, power the water cycle, and enable photosynthesis. Over long timescales, fluctuations in the sun's activity have a direct influence on global climate and are thought to be connected to past periods of significant planetary cooling and warming. To relax before you fall asleep, it can be very calming to picture the sun's gentle radiance as it bathes the planets of our solar system in light. Imagine its slowly shifting sunspots, its prominences glowing faintly in the vacuum of space, and the warmth of its rays reaching Earth, which all combine to create a profound sense of harmony, stability, and peace. Missions like the Parker Solar Probe and the Solar Orbiter are currently examining our star from unprecedentedly close distances, collecting vital data on the corona's structure, its magnetic fields, and the solar wind. This research allows us to gain a much deeper understanding of thermonuclear fusion and the dynamics of magnetic fields, while also enabling us to predict space weather. Such forecasts are absolutely essential for ensuring the safety of our satellites and protecting future crewed space missions from solar hazards. The sun, therefore, is far more than a simple source of light and heat. It is an active, dynamic star that holds a central role in the life of our planet and the entire solar system. By studying our star, you not only expand your knowledge of the cosmos, but also prepare us all for potential solar events and get to feel the sheer grandeur and harmony of the universe. The moon, our closest celestial companion, has long captivated humanity with its enigmatic beauty. As Earth's sole natural satellite, it orbits us at an average distance of approximately 384,000 kilometers. With a diameter of about 3,474 kilometers, which is roughly 1/4 that of our own planet, the moon exerts a powerful influence over life and natural processes here on Earth. The lunar surface presents a varied landscape, from the vast plains known as maria, which were formed by solidified lava billions of years ago, to towering mountain ranges sculpted by ancient meteorite impacts. These lunar craters, some of which are billions of years old, provide scientists with a unique record that helps them piece together the solar system's history and comprehend how planets and their satellites come into being. The regular cycle of lunar phases, including the new moon, first quarter, full moon, and last quarter, corresponds to the changing portion of the moon we can see from Earth. These predictable phases not only alter the brightness of the night sky, but have also been historically vital for creating calendars, guiding agricultural cycles, and shaping cultural rituals across civilizations. Furthermore, the moon's gravitational force is the primary driver of Earth's ocean tides, generating differences in water levels on opposite sides of our planet that are crucial for coastal ecosystems and that influence both climatic and geological processes. An interesting fact is that the moon is slowly drifting away from Earth at a rate of about 4 centimeters each year. This gradual separation causes our planet's rotation to slow down, which in turn lengthens our days. Millions of years in the past, a day on Earth was considerably shorter, and the moon appeared much closer in the sky. These ongoing dynamic shifts give scientists valuable clues for reconstructing the ancient history of both Earth and its natural satellite. From the historic Apollo program to the advanced robotic explorers of today, lunar missions have enabled us to analyze the composition of the moon's surface, its deep internal structures, and its regolith, the layer of loose, fragmented material covering its entirety. These investigations have shown that the moon holds reserves of oxygen, silicon, iron, magnesium, and other rare minerals, positioning it as a promising location for future human exploration and the establishment of lunar bases. The moon also offers some truly captivating visual events. For instance, during a lunar eclipse, when our planet passes directly between the sun and moon, sunlight is blocked, casting a reddish glow upon the lunar surface. The sight of the moon's brilliant disk hanging in the night sky has been a timeless source of inspiration for poets, artists, and scientific minds. To aid relaxation before sleep, you can try visualizing the moon's soft light, its serene journey across the sky, and its reflection of the sun, which can evoke a powerful feeling of harmony and tranquility. In this way, the moon reveals itself not merely as a satellite, but as an active participant in Earth's systems and a singular object for scientific inquiry. Studying it helps us grasp the dynamics of the solar system and the origins of planets and moons, while deepening our appreciation for the beauty and order of the cosmos. Meanwhile, the gas giants, Jupiter and Saturn, stand as the true titans of our solar system, captivating us with their immense size, intricate rings, and vast collections of moons. Jupiter, the largest planet, boasts a diameter of over 140,000 kilometers and a mass more than 300 times greater than Earth's. Composed almost entirely of hydrogen and helium, Jupiter is often described as a failed star, as it never accumulated enough mass to initiate thermonuclear fusion in its core. Its atmosphere is a theater of incredible dynamism, featuring massive vortices, powerful storms, and distinct cloud bands, including the famous Great Red Spot, a storm that has been raging for over 300 years and is large enough to swallow 2 Earths. Orbiting this giant are more than 90 moons, among which are the 4 large Galilean satellites. These include Io, the most volcanically active world in the solar system; Europa, whose icy shell is believed to hide a vast subsurface ocean; Ganymede, which holds the title of the largest moon in our entire solar system; and Callisto, distinguished by its ancient, heavily cratered surface. Saturn, the second largest gas giant, is celebrated for its breathtaking system of rings and possesses a diameter of around 120,000 kilometers, with a mass 95 times that of Earth. Much like Jupiter, Saturn's atmosphere is dominated by hydrogen and helium, with small amounts of methane and ammonia that contribute to its unique weather patterns and auroras. Its rings are truly one of the most stunning sights in the solar system, composed of billions of ice and rock particles that range in size from microscopic dust to enormous boulders. These particles form complex structures containing gaps, waves, and divisions, creating a dynamic and ever-shifting spectacle that missions like Cassini have studied to understand their composition and the gravitational influence of Saturn's moons. Finally, Jupiter and Saturn perform a vital function in safeguarding the inner solar system. Their tremendous gravitational pull acts like a cosmic shield, attracting and deflecting countless comets and asteroids that might otherwise pose a threat of collision with Earth. This protective role underscores the profound importance of these giant planets in preserving the stability of our solar neighborhood, allowing life on our own world to flourish in relative safety. To help you relax before sleeping, picture the magnificent gas giants. Imagine Jupiter, with its turbulent bands of clouds and colossal storms, turning slowly in the void of space. Then visualize Saturn, whose luminous rings and golden radiance inspire a profound sense of cosmic harmony and grandeur. Contemplating these images allows you to grasp the immense scale and beauty of the universe, fostering a state of relaxation and peace as you prepare for sleep. Beyond their calming presence, these colossal worlds serve as guardians of our solar system's stability. They are also unparalleled laboratories for investigating gas planets and their moons, acting as a constant wellspring of inspiration for both scientific inquiry and the human imagination. The ice giants, Uranus and Neptune, represent the most distant and enigmatic planets within our solar system, and much about them remains unknown to us. Uranus, the seventh planet from the Sun, has a diameter of roughly 50,000 kilometers, almost 4 times that of our own world, and possesses a mass 14 times greater than Earth's. The planet's most remarkable quality is its axial tilt of nearly 98 degrees, which results in it spinning almost on its side relative to its orbit. This extreme orientation leads to extraordinary seasons, where each pole is bathed in sunlight for 42 years before being plunged into an equal period of total darkness. Composed primarily of hydrogen and helium, the atmosphere of Uranus also contains traces of methane, which is responsible for the planet's distinctive blue-green color. This methane gas absorbs the red portion of the light spectrum while reflecting blue and green wavelengths, which contributes to its cold and mysterious appearance. In fact, with temperatures in its upper atmosphere plummeting to minus 220 degrees Celsius, Uranus holds the title of the coldest planet in the solar system. Discovered in the 1990s, a system of slender, dark rings made of ice and dust encircles Uranus. While they are far less conspicuous than the rings of Saturn, they are nonetheless critical to the planet's dynamics. Uranus is also accompanied by 27 known moons, the largest of which include Titania, Oberon, Umbriel, Ariel, and Miranda. One of these moons, Miranda, is especially fascinating due to its complex and fractured surface, which displays deep canyons, towering icy plateaus, and immense fault lines. Moving outward, we encounter Neptune, the 8th planet from the Sun. It is slightly smaller than Uranus, with a diameter of about 49,000 kilometers, but its mass is nearly 17 times that of Earth. Situated at an average distance of 4.5 billion kilometers from the Sun, Neptune's sheer remoteness poses a significant challenge for observation and study. Its atmosphere shares a similar composition to that of Uranus, containing hydrogen, helium, and methane, which gives it a vibrant, deep blue appearance. Neptune is particularly known for its ferocious winds, which can reach speeds over 2,000 kilometers per hour, making them the fastest in the entire solar system. Within its atmosphere, Neptune hosts gigantic storms, such as the Great Dark Spot, a storm system with dimensions comparable to our own planet. These tempests are constantly shifting, altering their form and fluctuating in strength, which results in a highly dynamic and ever-changing atmospheric landscape. Neptune possesses its own faint ring system and is orbited by 14 known moons. The largest moon, Triton, is exceptional because it travels around the planet in the opposite direction of Neptune's rotation, a trait suggesting it was likely captured from the Kuiper Belt. Triton's frozen surface, geysers of nitrogen, and unusual geology make it a key object for understanding how icy bodies evolve in our solar system. To find calm before you sleep, try picturing these far-off worlds. See Uranus, spinning on its side, encircled by its icy rings, and shrouded in a frozen blue atmosphere. Then imagine Neptune, mysterious and energetic, with its swift winds and brilliant blue glow. These mental images can conjure a feeling of cold, quiet beauty and an appreciation for the cosmos's vastness, helping you find harmony and tranquility. Ultimately, the ice giants are singular worlds defined by extraordinary characteristics that continue to perplex scientists. They serve as a powerful motivation for explorers and stand as a testament to the incredible diversity of planets that exist within our solar system. Dwarf planets and the objects within the Kuiper Belt are remote and mysterious worlds orbiting beyond Neptune, and they hold vital clues to the origins and evolution of our solar system. The Kuiper Belt itself is a massive region, stretching from approximately 40 to 55 astronomical units from the Sun, and it is populated by an immense number of icy bodies and dwarf planets. These objects, which are primarily made of water ice, ammonia, methane, and rocky material, vary in size from just a few kilometers to thousands of kilometers in diameter. Pluto, one of the most well-known inhabitants of the Kuiper Belt, was found in 1930 and was for a long time classified as the ninth planet. With a diameter of about 2,300 kilometers, its mass is nearly 50 times less than Earth's. Pluto is orbited by 5 known moons, the most prominent being Charon, which is almost half the size of Pluto itself. What's remarkable is that Pluto and Charon are tidally locked, meaning they perpetually show the same hemisphere to one another in a perfectly synchronous dance. Another dwarf planet in the Kuiper Belt is Eris, which was discovered in 2003 and is slightly smaller than Pluto but actually more massive. Eris is orbited by a moon named Dysnomia and is considered a critical body for researching gravitational forces and the dynamics of distant celestial objects. By studying Eris and its peers, scientists gain a deeper understanding of planetary formation and the processes at play at the edge of our solar system. Numerous other Kuiper Belt objects, including Makemake, Haumea, and Sedna, exhibit their own unique traits. Haumea, for instance, has a distinctively elongated shape and spins with such extreme rapidity that it appears flattened. Makemake is notable for its reddish surface, which may be caused by the presence of organic compounds, whereas Sedna follows an incredibly distant orbit, positioning it as one of the most remote known objects in our solar system. Dwarf planets and Kuiper Belt objects are also crucial to the creation of comets. It is believed that many of the long-period comets we observe from Earth originate in these distant regions. Studying them provides invaluable insight into the chemical makeup and dynamic processes of the early solar system, as these objects essentially serve as reservoirs of primordial material, preserving their original state from the time of planetary formation. To find tranquility before sleeping, I find it helps to picture those far-off realms. Dwarf planets in their slow spin, icy comets tracing silent paths, and the deep blackness of space, imbued with a profound sense of harmony. Envisioning these cold, distant worlds allows you to grasp the sheer scale of the solar system, which can bring about a feeling of deep calm. These bodies, like the dwarf planets and the objects of the Kuiper Belt, are more than just remote points of light. They are invaluable archives holding secrets about the dawn of the cosmos, the ancient mechanics of planet formation, and the ongoing dynamic forces shaping our cosmic neighborhood. While small, asteroids and meteorites are objects of immense importance within the solar system, as they contain vital clues about its origins and the way planets came to be. Asteroids themselves are celestial bodies of rock and metal that circle the Sun. You'll find the majority of them concentrated in the asteroid belt, a region between Mars and Jupiter, where the immense gravitational influence of Jupiter disrupted the creation of a complete planet. The dimensions of these objects vary greatly, from just a few meters across to hundreds of kilometers. The most massive asteroids, including Ceres, Vesta, and Pallas, are so large they are often regarded as miniature planets. Ceres, discovered in 1811, is the most substantial object in the asteroid belt, measuring about 900 kilometers in diameter. Its surface is a composite of ice and rock, and data from the Dawn mission uncovered salt deposits, which points to the potential existence of underground water in its history. Vesta is distinguished by its varied terrain and craters that bear the scars of ancient impacts, whereas Pallas, at nearly 600 kilometers wide, spins so quickly that its own shape has become slightly distorted. When fragments from asteroids or other celestial bodies survive their journey through our atmosphere and land on Earth, we call them meteorites. These remnants, which can be stony, metallic, or a mix of both, give scientists a direct way to examine the chemical makeup and age of primordial material from the solar system's earliest days. Remarkably, certain meteorites carry organic molecules and amino acids, providing crucial insights that help us piece together the puzzle of life's beginnings and the environment of the young Earth. Beyond their scientific value, asteroids and meteorites are a serious consideration for planetary safety. History shows us that major impacts have triggered dramatic climate shifts and even mass extinctions, the most famous of which is the event some 66 million years ago that played a role in wiping out the dinosaurs. Consequently, modern astronomers diligently track near-Earth objects, or NEOs, to forecast possible impacts and devise protective strategies, such as deflecting or breaking apart any approaching threats. It's also fascinating to consider that these celestial bodies represent a potential source of resources for humanity's future in space. A great number of them are rich in metals, rare earth elements, and water, materials that could be invaluable for building off-world bases and supporting life. The concept of asteroid mining is no longer just science fiction. It's a field of active research that could very well become a practical reality within a few decades. To wind down before sleep, you can try visualizing these rocky worlds making their slow pilgrimage around the sun. Picturing asteroids with their cratered, irregular surfaces and mineral deposits glinting in the sunlight can instill a feeling of immense age and stability. Meanwhile, imagining meteorites as silent fireballs streaking through our sky serves as a beautiful reminder of Earth's connection to the wider solar system. These mental images reinforce the harmony and vastness of space, paving the way for a restful night. So you see, they are far more than just space rocks. They are messengers from the past, resources for the future, and a constant reminder of our planet's place in the cosmos. In the solar system, comets are truly majestic and enigmatic travelers, composed of ice, dust, and frozen gases. They follow long, stretched-out orbits that periodically bring them close to the sun, where they develop their brilliant tails. A comet has three main parts: a nucleus, a coma, and a tail. The nucleus is the solid core, which can be anywhere from a few hundred meters to tens of kilometers wide, and is a mixture of water ice, frozen gases like carbon dioxide and ammonia, and rocky particles. As the sun's heat warms the nucleus, it forms the coma, a glowing cloud of gas and dust. This same solar energy causes the ices to sublimate, and the resulting material is pushed away by the solar wind to form the iconic tail, which can extend for millions of kilometers and always points away from the sun. The vast majority of comets come from two specific zones in the outer solar system: the Oort cloud and the Kuiper belt. The Oort cloud is theorized to be an immense spherical shell of icy bodies, reaching out as far as 200,000 astronomical units from the sun, and it is from here that long-period comets emerge. In contrast, the Kuiper belt, a disk-shaped region beyond the orbit of Neptune, gives rise to short-period comets. the most famous of which is Halley's Comet, completing its journey around the Sun roughly every 76 years. Comets are critically important for our understanding of the early solar system because their composition is a preserved record of the chemical elements and organic compounds that were present billions of years ago. By studying them, we gain insights into how planets formed and how water and organic matter were distributed, which helps explain the origin of water on our own planet. The Rosetta spacecraft mission, which rendezvoused with comet Churyumov-Gerasimenko in 2014, is a prime example of this research. It's also believed that comets have directly affected life on Earth, possibly delivering water and essential organic materials through impacts, thereby helping to create the conditions for life to arise. As a final thought for relaxation before you sleep, I suggest you try picturing a comet on its slow, graceful journey toward the Sun. Imagine its icy core beginning to glow as it catches the light, the coma forming a soft, luminous halo around it, and its spectacular tail unfurling behind it like a silver ribbon stretched across the immense canvas of space. By providing a profound sense of tranquility, splendor, and balance, these cosmic images invite you to grasp the sheer scale and enigma of the universe, preparing you for a restful night. Comets, therefore, are far more than mere luminous points in the sky. They are emissaries from the depths of space. As custodians of primordial materials and providers of insight into our solar system's water and organic compounds, they offer an inspiring spectacle that connects you to the immense beauty of the cosmos. The magnetic fields of planets are potent, invisible structures that safeguard atmospheres, generate auroras, and mediate the flow of the solar wind. This planetary magnetism originates from the churning of a liquid metallic core in a process called the geodynamo. For our world, the motion of molten iron and nickel in the outer core produces an enormous magnetic flux that defines Earth's protective field. Extending far beyond our atmosphere, Earth's magnetic field establishes the magnetosphere, a shield that repels charged particles from the solar wind and protects the planet from harmful radiation. This solar wind is a continuous stream of particles flowing from the sun at speeds reaching 800 kilometers per second. When this stream collides with the magnetosphere, the resulting interactions ignite the auroras, which you can see near the poles as the northern and southern lights. The auroras are not only beautiful displays, but also visual indicators of the intricate dance between our planet's magnetic field and solar plasma. Earth is not alone in possessing such a shield. Jupiter boasts the most powerful magnetic field in the solar system, one that is 28 times stronger than our own. Its magnetosphere is so vast, it stretches for millions of kilometers, enveloping its moons and forming intense radiation belts, while Saturn, Uranus, and Neptune also exhibit their own unique magnetic structures. Magnetic fields are crucial not just for shielding planets, but also for revealing their internal composition. By analyzing the fluctuations in these fields, scientists can deduce information about a planet's core, its speed of rotation, and the state of materials deep inside. For instance, monitoring changes in Earth's magnetic field is vital for predicting magnetic storms that could disrupt satellites, radio communications, and power systems. To help you relax before sleeping, try to envision the invisible lines of this magnetic field arcing from pole to pole, creating a protective dome around our world. See the solar wind flow around this shield, sparking the gentle, shimmering glow of the auroras in hues of green, red, and purple. These planetary magnetic fields are our silent protectors, shaping cosmic interactions, painting the sky with light, and preserving the conditions necessary for life. Gravity is the unseen force that dictates the paths of planets, moons, and asteroids, occasionally producing anomalies that expose new cosmic mysteries. These gravitational anomalies are variations in the gravitational pull of a celestial body, stemming from an uneven distribution of mass within or the pull of nearby objects. They are key tools for exploring planetary interiors, orbital mechanics, and the movement of celestial bodies through the solar system. Here on Earth, these gravitational irregularities appear as localized shifts in the force of gravity, which are charted by satellite missions like GRACE and GOCHI. The data collected from orbit allows scientists to map subterranean geological formations, track ocean currents, and monitor the distribution of ice across the globe, giving us a clearer picture of our planet's dynamic systems. Throughout the solar system, gravitational anomalies are also found on the Moon, Mars, and the gas giants. For example, missions to the Moon have identified dense concentrations of mass called mascons, which are linked to ancient impact craters now filled with heavy rock. These mascons significantly influence the trajectories of orbiting spacecraft, requiring meticulous calculations for any planned landing. Studying the intricate motions of asteroids and comets also relies on understanding gravitational anomalies. Minor variations in the gravitational fields of planets can subtly but steadily shift an asteroid's course over long periods. Scientists must account for these effects, which resemble a silent celestial ballet, to accurately predict any potential collisions with Earth. Of special fascination are the Trojan asteroids, which occupy Lagrange points, areas of gravitational stability between a planet and the Sun. Jupiter, for instance, shepherds thousands of these asteroids within its Lagrange points, where the gravitational pull from the Sun and the gas giant perfectly balances the asteroid's motion. These objects offer invaluable clues about how our solar system formed and maintains its orbital stability. As you prepare for sleep, visualize planets and their moons in their slow, majestic rotation, their invisible gravitational fields interacting in a cosmic dance. Imagine their orbits gently swaying and bending due to the influence of their neighbors, while asteroids and comets trace elaborate paths. This vision of underlying harmony and order in the universe can help guide you into a state of calm, peaceful rest. Among the most breathtaking sights in the cosmos are the spiral galaxies, which are enormous rotating systems of stars, gas, and dust arranged in graceful, swirling patterns. These galaxies typically feature a dense central bulge from which spiral arms unfurl into a surrounding disk. It is within these arms that you find concentrations of young, brilliant stars and vast clouds of cosmic gas, the stellar nurseries of the universe. Among the most spectacular sights in the universe are spiral galaxies, which are enormous, rotating collections of stars, gas, and dust shaped into graceful, swirling arms. These arms are what give the galaxy its signature spiral appearance when you view it through a telescope. At the heart of nearly every spiral galaxy, you'll find a supermassive black hole, possessing a mass that can be millions or even billions of times greater than our Sun. Our own galaxy, the Milky Way, serves as a classic example of a spiral galaxy, stretching over 100,000 light-years in diameter. It is home to hundreds of billions of stars, along with countless gas clouds, star clusters, and nebulae. Our solar system resides about 27,000 light-years away from the galactic core, nestled within one of the spiral arms called the Orion arm. It's important to understand that these spiral arms are not fixed structures. Instead, they are waves of density that travel through the galaxy's stellar disk. As one of these waves passes through a region, it compresses the gas clouds, triggering vigorous star formation. This dynamic process transforms spiral galaxies into bustling hubs of stellar birth. One of the most fascinating aspects of spiral galaxies is their rotation. Observations reveal that the velocity of stars in the outer arms remains almost constant, regardless of their distance from the center, a finding that defies Newton's laws of gravity when only visible matter is considered. This discrepancy provided some of the earliest compelling evidence for the existence of dark matter, an unseen substance that interacts with the galaxy only through its gravitational pull. To help yourself unwind before sleep, I suggest you try picturing a spiral galaxy, with its majestic arms shimmering with stars of countless colors and brightness levels. Envision luminous clouds of gas slowly churning, sparking the creation of new suns, all while a brilliant, massive core glows at the center. This cosmic panorama can instill a profound sense of tranquility, scale, and the universe's grandeur, which may quiet your thoughts and guide you toward a restful sleep. Therefore, spiral galaxies are far more than just breathtaking cosmic photographs. They are incredibly dynamic systems where stars are constantly being born, density waves propagate, and the unseen influence of dark matter orchestrates a magnificent and large-scale cosmic dance. Elliptical and irregular galaxies, while less distinct in shape, are equally captivating galactic systems that showcase the incredible variety of cosmic structure and evolution. Elliptical galaxies are characterized by an elongated ball-like shape and are composed almost entirely of ancient red stars, containing very little gas or dust. Consequently, the processes of star formation have nearly ceased within them, leaving them as cosmic relics that have been preserved since the early days of the universe. Their diameters can vary dramatically, from just a few thousand to over 1 million light-years, ranking them among the most massive objects known to exist. Unlike spiral galaxies, elliptical galaxies exhibit a more uniform and symmetrical structure, completely lacking any defined arms. The stars within them follow orbits that are oriented in many different directions, which collectively generates their spherical or ellipsoidal form. Deep within these galaxies, it's possible to find colossal black holes that govern the motion of all the nearby stars. Irregular galaxies are even more curious, as their forms do not fit any simple classification and possess neither a spiral structure nor a smooth elliptical shape. These galaxies are frequently the outcome of gravitational interactions and mergers with other galaxies, which results in a chaotic arrangement of stars, gas, and dust. A prime example can be seen in the Magellanic Clouds, which are satellite galaxies to our own, and are classified as irregulars with ongoing star formation. Both elliptical and irregular galaxies are crucial for your understanding of how the universe has evolved. They provide insights into how galaxies can age, deplete their gas reserves, stop forming new stars, and engage in cosmic collisions. By observing these galactic types, astronomers can better calculate the expansion rate of the universe, investigate dark matter, and reconstruct how the largest cosmic structures, such as galactic clusters and superclusters, came into being. For a relaxing exercise before you drift off to sleep, try visualizing a magnificent elliptical galaxy, its serene stars spread evenly throughout its volume. Or perhaps a chaotic, irregular galaxy, ablaze with bright pockets of new star formation. Imagine the soft glow created by millions of stars as they slowly rotate and twinkle, immersing you in a feeling of infinite space and cosmic serenity. These mental images can help soothe your mind and prepare it for a deep and peaceful rest. In essence, elliptical and irregular galaxies represent some of the most ancient and varied galactic forms in the cosmos. They offer a window into the evolution of star systems, reveal the transformative power of collisions and mergers, and display the profound beauty found in both cosmic order and chaos. Dark matter stands as one of the most enigmatic and compelling subjects in contemporary astronomy. This substance doesn't emit or reflect light and doesn't engage with normal matter through familiar forces, yet you can detect its gravitational presence throughout the universe. The concept of dark matter arose when scientists noted a significant mismatch between a galaxy's observable mass from its luminous stars and the mass derived from the rotational speed of its disk. Stars on the peripheries of galaxies were observed to be moving much faster than they should if only visible matter were holding them in their orbits. This observation led to the unavoidable conclusion that a vast amount of unseen mass, which was named dark matter, must be present to provide the necessary gravitational cohesion for galaxies. Astronomers employ a variety of methods to study dark matter. Techniques such as cosmic microlensing, observations of gravitational lensing, and detailed mapping of the movement of stars and gas enable scientists to approximate its distribution. Gravitational lensing, in which immense clusters of dark matter warp the light from distant galaxies, allows us to map its shape and structure, even though the substance itself remains completely invisible to you. Dark matter does more than just bind individual galaxies together. It is also the primary architect of the universe's large-scale structure. It establishes a vast cosmic web, a sort of scaffolding along which galaxies and galaxy clusters are arranged. You can picture it as invisible filaments guiding the flow of matter, creating immense cosmic bridges that connect galactic systems and shape the overall architecture of the cosmos. Despite decades of intensive investigation, the true nature of dark matter continues to elude us. The leading hypothesis suggests it is a completely new form of exotic matter, consisting of particles that have an exceedingly weak interaction with the ordinary matter that makes up everything you can see and touch. Around the globe, scientists are constructing detectors designed to capture these elusive particles and unravel their secrets, a discovery that promises to transform our comprehension of both physics and the universe itself. To help you relax before sleeping, try picturing dark matter as unseen filaments interlacing the cosmos, creating the very scaffolding for galaxies and linking star clusters together. You can envision brilliant galaxies suspended on these invisible strands, gently glimmering in the boundless expanse of space. This kind of mental imagery can instill a profound feeling of the universe's immense scale and harmony, guiding your mind toward a state of peace and quiet. Consequently, dark matter stands as an unseen but essential component of the cosmos. It sculpts the universe's architecture, anchors galaxies in place, and represents one of contemporary science's most profound enigmas, sparking both our imagination and our sense of awe. Among the most perplexing and fascinating phenomena in the cosmos is dark energy, an invisible substance that emits no light and avoids conventional interactions with matter, yet its presence is undeniable in the accelerating expansion of the universe. Its discovery came in the late 1990s, when astronomers studying faraway supernovae observed that the universe's expansion was speeding up. This finding flew in the face of traditional gravitational theories, leading to the astonishing realization that some unknown force was actively pushing galaxies apart. Making up approximately 70% of the total energy in the cosmos, dark energy is the prevailing ingredient of space, and its uniform distribution sets it apart from dark matter. This pervasive force is responsible for driving galaxies away from one another with increasing velocity. One leading hypothesis suggests dark energy is an intrinsic property of space itself, a form of vacuum energy, while ongoing research using telescopes and observations of the cosmic microwave background continues to probe its true nature. The destiny of our universe is also shaped by dark energy, as its persistent influence means the cosmic expansion will carry on, causing galaxies to drift progressively further from one another. This points to a distant future where space appears vast, empty, and cold, a humbling prospect that underscores the cosmos's scale and dynamism. For relaxation, you can envision dark energy as an unseen current, gently widening the space between galaxies much like a cosmic breeze, stretching the very fabric of existence, cultivating a feeling of limitless serenity. Visualizations like these can prepare your mind for a restful night by immersing your imagination in the sheer majesty and beauty of the cosmos. Ultimately, dark energy is an invisible but foundational force propelling the universe's accelerated expansion, raising profound questions about reality's nature and the future of space itself, all while firing the imagination and inspiring wonder at our immense universe. Contrary to what you might think, space is not a complete void. Even in areas that appear empty, there are tenuous particles, fields, and plasma that foster the conditions necessary for stars, galaxies, and planets to exist. The cosmic vacuum itself is a region with incredibly low pressure and a particle density of just a few atoms per cubic meter. Yet even this seemingly barren expanse is not truly empty, as it is permeated by cosmic rays, electromagnetic fields, and microwave radiation. Within galaxies, the interstellar medium, composed of very diffuse gas and dust, plays a crucial part in their life cycle. Vast clouds made mostly of hydrogen and helium provide the right environment for new stars to form. Once a cloud's density passes a certain threshold, the force of gravity initiates its collapse, leading to the formation of a protostar that will eventually ignite into a mature star. The most abundant state of matter in the universe is plasma, which is an ionized gas made up of free-floating electrons and positively charged ions. You can find this plasma not only within stars, but also filling the interstellar and intergalactic voids. Because it conducts electricity and responds to magnetic fields, plasma drives intricate and dynamic events like solar flares, magnetic storms, and powerful cosmic winds. Both cosmic plasma and the interstellar medium influence how light and radio waves travel, producing effects like scattering and refraction. These very interactions are what allow us to witness stunning nebulae, clouds of gas and dust lit up by the glow of nascent stars. Famous examples such as the Eagle Nebula, the Orion Nebula, and the Crab Nebula all act as invaluable natural laboratories where we can observe the processes of star birth firsthand. To help you relax before sleeping, try to envision cosmic space not as empty, but as a vast and wonderfully vibrant field. Imagine tenuous plasma flowing between the stars, emitting a faint luminescence, as interstellar clouds drift softly in zero gravity. As you picture starlight filtering through these translucent structures, you can evoke a feeling of immense depth, eternity, and balance, which helps prepare your mind for a deep and peaceful rest. Therefore, the cosmic vacuum, plasma, and interstellar medium are far more than a simple backdrop for celestial objects. They are dynamic participants in the universe's evolution. They actively shape cosmic life, generate the motion and beauty we observe in space, and empower us to conceive of the majesty of the unseen and the infinite. You will find magnetic fields nearly everywhere in the universe, extending from individual planets and stars to the vast expanses of entire galaxies and the space between them. Although these fields are invisible, they exert a profound effect on the motion of particles, the development of star systems, and the overall dynamics of the cosmos. On a planetary scale, like here on Earth, these magnetic fields are produced by the churning of liquid metal deep within the planet's core. Your planet is shielded by a magnetic dipole, a crucial defense against the solar wind, a relentless flow of charged particles streaming from the sun. If this protective barrier did not exist, the constant bombardment from these particles would gradually strip away our atmosphere, making life on the surface completely unsustainable. Stellar magnetic fields operate on a much more magnificent scale, where their lines can twist and interact with plasma, triggering dynamic events like solar flares and coronal mass ejections. These processes unleash vast amounts of energy into the cosmos, influencing space weather. Even larger are galactic magnetic fields, which span hundreds of thousands of light years, helping to guide the flow of gas, shape spiral arms, and even initiate the birth of stars within giant nebulas. These cosmic magnetic fields also generate unique and observable effects, which allow you to witness their power. For example, radio waves produced by accelerating electrons within these fields enable astronomers to map invisible plasma and analyze the dynamics of distant galaxies. You can envision these fields as invisible conductors that orchestrate the motion of particles, sculpt cosmic structures, and instill a deep harmony in space. To help you relax before sleeping, I suggest you visualize the invisible lines of these magnetic fields weaving through space, gently guiding the currents of plasma and light around stars and galaxies. Picture these unseen forces establishing a rhythm of cosmic movement, much like music expanding slowly and smoothly through an infinite void. This mental image can evoke a profound sense of depth and harmony in the universe, preparing your mind for a peaceful rest. So, although they are invisible, cosmic magnetic fields are powerful agents that govern the movement of matter and the formation of structures throughout the universe, bringing order to chaos. But space is not just defined by these forces and vast objects. It is also filled with countless smaller bodies in orbit. These objects, comets, asteroids, and meteoroids, serve as a record of our solar system's formation and history. Comets can be thought of as cosmic, dirty snowballs, a mixture of ice, dust, and frozen gases originating from the frigid outer regions of the solar system, known as the Kuiper Belt and the Oort cloud. When a comet's orbit brings it close to the sun, its ices begin to vaporize, creating a spectacular tail of gas and dust that can stretch for millions of kilometers as it glides gracefully through space. In contrast, asteroids are solid, rocky, or metallic objects whose sizes range from just a few meters to hundreds of kilometers in diameter. Most are concentrated in the asteroid belt between Mars and Jupiter, but some follow paths that bring them near Earth, reminding you of the dynamic and ever-changing nature of space. Studying them helps us piece together the processes of planetary formation and the chemical makeup of the early solar system. The interplanetary journeys of these bodies are astonishingly diverse. As comets and asteroids travel along their orbits, they sometimes collide, which can alter their trajectories and create streams of debris. When these particles enter a planet's atmosphere, they burn up, producing the brilliant meteor showers you can observe from Earth, such as the Perseids or the Leonids. It is a fascinating possibility that comets and asteroids were messengers from deep space, carrying organic molecules and water within them. Some scientists propose that these bodies delivered these essential ingredients to the young Earth, thereby helping to establish the conditions necessary for life to emerge. They may have been the very catalysts for the beginning of biology on our world. For a moment of relaxation before you go to sleep, try to imagine these cosmic travelers gliding slowly through the weightlessness of space, See the comets with their long glowing tails, the asteroids in their silent orbits around the sun, and meteors streaking through the atmosphere like soft sparks in the night. These images can fill your imagination with a sense of the universe's grandeur and harmony, bringing you a feeling of calm and wonder. Therefore, you should see comets, asteroids, and interplanetary bodies not as mere cosmic debris, but as ancient witnesses to the solar system's history and active participants in its ongoing dynamics. Their presence reminds you that space is not a calm and empty void. Rather, it is filled with powerful processes that can generate true storms of energy and particles. The solar wind is one such process, a continuous stream of charged particles flowing outward from the sun. This current, made up of electrons, protons, and alpha particles, traveling at hundreds of kilometers per second, spreads throughout the solar system, interacting with planetary magnetic fields to create phenomena such as auroras. Even more dramatic are coronal mass ejections, which are powerful eruptions of plasma and magnetic fields from the sun's surface. These events can propel massive amounts of matter at speeds of millions of kilometers per hour. If such an ejection is aimed toward a planet, its collision with the magnetosphere can trigger powerful magnetic storms, affecting radio communications and even power grids on the surface. Auroras are one of the most spectacular results of the solar wind's interaction with a planet. As charged particles collide with atoms and molecules in the atmosphere, they excite them, causing them to glow and produce magical dancing lights across the sky. While you know them on Earth, they also appear as giant luminous arcs around the poles of Jupiter and Saturn, demonstrating that the effects of these cosmic storms can be felt throughout the solar system. Because Mars lacks a protective magnetic field, its atmosphere is steadily stripped away by the solar wind, which casts its particles out into the void of space. This process is the reason the Martian atmosphere is so much more tenuous than Earth's, and why its surface is left vulnerable to solar radiation. To relax before you fall asleep, I suggest you picture this solar wind not as a destructive force, but as a tranquil stream of light and energy flowing through the cosmos, washing over planets and stars in a cosmic dance that fosters a sense of universal harmony. Over the last few decades, astronomers have confirmed the existence of thousands of planets outside of our solar system, which we call exoplanets. These distant worlds are astounding in their variety, prompting new inquiries into how planets form and where life might exist. Exoplanets can range from gas giants that dwarf Jupiter to compact rocky worlds similar in size to Earth or Mars. Some of these planets orbit incredibly close to their parent stars, enduring blistering temperatures, while others reside within a habitable zone where conditions might permit the existence of liquid water. Scientists rely on several clever techniques to detect these faraway exoplanets. One primary approach is the transit method, which involves monitoring a star for the subtle dip in its brightness that occurs when a planet crosses in front of it. Another is the radial velocity method, which measures the slight wobble in a star's position caused by the gravitational tug of an orbiting planet. Although more difficult, direct imaging methods are also used, but they must overcome the overwhelming glare of the host star. What's fascinating is the sheer strangeness of some of the exoplanets we've found. There are worlds known as hot Jupiters, which are massive gas giants that circle their stars at extremely close range, subjecting them to unimaginable heat. We have also discovered super-Earths, rocky planets larger than our own that could possess thick, substantial atmospheres. The dynamic and sometimes chaotic nature of planetary system formation is revealed by planets with unusual orbits, from perfectly circular paths to highly elongated ones, with some even on a collision course with their neighbors. Studying exoplanets gives us a crucial window into the conditions under which planetary systems arise, and offers clues as to why Earth is uniquely suited for life. By using spectroscopy to analyze the light passing through their atmospheres, we can identify molecules like water, methane, and carbon dioxide, which is a vital component of astrobiological research. To prepare for a night of restful sleep, you can let your imagination drift to these exoplanetary systems, picturing yourself on the surface of alien landscapes, where oceans of lava might burn, or icy plains are softly lit by a foreign sun. Black holes represent some of the most profound and astonishing objects known to exist in the universe, challenging our fundamental concepts of space, time, and matter. A black hole is a region of space-time where gravity is so intense that nothing, not even light, can break free. This point of no return is known as the event horizon, and while we cannot see a black hole directly, we can detect its immense influence on the stars and gas clouds that surround it. The most commonly known black holes are born from the deaths of massive stars. When such a star exhausts its fuel, its core collapses under its own weight, sometimes triggering a supernova explosion, while the core itself compresses into an object of incredible density. The resulting black hole can have a mass several times that of our Sun, with a gravitational pull so powerful that it visibly warps the fabric of space-time in its vicinity. At the heart of most galaxies, including our own Milky Way, lie supermassive black holes with masses equivalent to millions or even billions of suns. These cosmic behemoths are the anchors of their galaxies, dictating the orbits of stars and gas, and creating powerful jets of energy that can stretch for thousands of light years. Their existence and behavior are absolutely central to the evolution of the galaxies they inhabit. The physics surrounding black holes leads to bizarre effects that sound like they belong in science fiction. For instance, time itself appears to slow down as you approach the event horizon, and the path of light is bent by the intense gravitational field. Scientists can observe these relativistic phenomena, such as gravitational lensing, where the light from a distant star is warped around a black hole, producing unique and distorted images for our telescopes to capture. As you relax before sleeping, I encourage you to think of a black hole not as a source of dread, but as a mystical object guiding everything around it into a smooth, silent, and invisible dance. Imagine standing near the edge of the event horizon, watching as light flows along curved pathways and space-time itself moves with a slow, deliberate grace. This vision can help you connect with the grandeur and mystery of the universe, bringing a sense of profound peace and tranquility. When you gaze out into the boundless cosmos, you are seeing more than just immense physical complexity. You are witnessing an incredible underlying harmony. The universe impresses us not only with its sheer scale, but also with its breathtaking structure. In a complex and beautiful system governed by the laws of physics, galaxies, stars, planets, and comets all interact, moving together in a vast and intricate cosmic ballet. While cosmic systems may appear disordered at first glance, a deeper look reveals a profound internal coherence. Consider how planetary orbits maintain their stability across millions of years, how stars are born and develop in accordance with the principles of nuclear physics, and how auroras on planets are guided by the recurring cycles of solar activity. The splendor of the cosmos is also powerfully expressed through its luminous displays. The northern lights, the tails of comets, the radiance of far-off nebulae, and the brilliance of star clusters all evoke the feeling of a magnificent work of art sculpted by nature itself. Every ray of light and each celestial glimmer is the product of energy, matter, and gravity, interacting to paint stunning scenes that you can witness from Earth, either with the naked eye or through a telescope. You can also perceive cosmic harmony in the cyclical rhythm of its events. Stars are born, exist for millions or billions of years, and then release their material back into the void, seeding new generations of stars and planets. The laws of mechanics dictate the precise paths of orbiting worlds, while solar winds and magnetic fields generate phenomena that are both dynamic and foreseeable. Even the most intense upheavals, like cometary impacts or coronal mass ejections, are merely beats in the endless rhythm that sustains galactic equilibrium. To help you relax before sleeping, it can be beneficial to envision the universe as a grand, biological entity in which every planet, star, and asteroid contributes to a single, immense, and harmonious living cosmos. You might picture the slow rotation of galaxies, the gentle glow of billions of suns, and the unseen but palpable flow of energy as cosmic winds sweep particles across space. This mental picture can foster a sense of serenity, quietude, and a profound connection to the vastness of everything. As we conclude our discussion, it's crucial to acknowledge that space serves as both a subject of science and a wellspring of inspiration. It nurtures our curiosity, encourages discovery, and instills a reverence for the laws of nature. At the same time, its elegance and order provide a way for you to find inner peace and comprehend your own position in the universe. By observing the stars, planets, and cosmic events, you become a participant in this magnificent symphony, where every deliberate glance at the night sky can be a source of both delight and calm.